Hey guys, welcome back to my channel. So I'm sure we all saw the same headlines last week. It's another round of life on Mars, thumbnails and headlines, and really the next chapter in the story that we've been talking about on this channel since last year. Remember that rock that Perseverance found last year that to all of us just looked like a rock, but it apparently made the scientific community take a collective gasp? Well, it turns out that Perseverance has been hard at work studying this rock with all of its scientific instruments, and that work recently turned into a peer-reviewed published paper in the journal Nature. And this paper asserts that there are definitely possible biosignatures in pieces of this Martian rock, but possible still being the operative word here. Basically, we took a picture of a rock, thought that it looks like some biosignatures, we studied this rock, still really feeling the biosignatures, and now we want to see this rock in person, IRL, as the kids say. But is that possible? What are the next steps for getting a Martian rock back to Earth, and what even are biosignatures? But don't worry, I started us on this journey, and I will take us to this next chapter of, can we prove that there was life on Mars? So on September 10th, 2025, the Perseverance team announced it found possible biosignatures in pieces of a Mars rock called Shavaya Falls that the rover first studied last year. The sample, dubbed Sapphire Canyon, was collected by NASA's Perseverance Mars rover in an ancient dry riverbed called the Jezero Crater. And the group of rocks in this area was dubbed the Bright Angel Formation. And what exactly are these biosignatures anyway? Well, according to NASA, a potential biosignature is a substance or structure that might have a biological origin but requires more data or further study before a conclusion can be reached about the absence or presence of life. So I think it's like a definite maybe about life. Nikki Fox, the Associate Administrator of NASA's Science Mission Directorate, I feel like I've said that title so many times. Have I not said that title like so many times? Can we just all agree we all know who Nikki Fox is? I'll just say Nikki Fox maybe from now on. So Nikki Fox said, "This finding is the direct result of NASA's effort to strategically plan, develop, and execute a mission able to deliver exactly this type of science, the identification of a potential biosignature on Mars. With the publication of this peer-reviewed result, NASA makes this data available to the wider science community for further study to confirm or refute its biological potential." So how exactly did we get this new information for this study? Well, like I said in the intro, from Perseverance himself. NASA used the rover's own scientific instruments to discover all kinds of new info. For example, the rover's science instruments found that the formation's sedimentary rocks are composed of clay and silt, which on Earth are excellent preservers of past microbial life. They are also rich in organic carbon, sulfur, oxidized iron, aka rust, and phosphorus. Perseverance scientist Joel Hurwitz of Stony Brook University and lead author of the paper said, "The combination of chemical compounds we found in the Bright Angel Formation could have been a rich source of energy for microbial metabolisms. But just because we saw all these compelling chemical signatures in the data didn't mean we had a potential biosignature. We needed to analyze what that data could mean." First to collect data on this rock were Perseverance's Pixel and Sherlock instruments. Pixel is the planetary instrument for X-ray lithochemistry, and Sherlock is the scanning habitable environments with Raman and luminescence for organics and chemicals. While investigating Shavaya Falls, which measures about 3 feet by 2 feet or 1 meter by a half meter, these instruments found what appeared to be colorful spots. The spots on the rock could have been left behind by microbial life if it had used the raw ingredients, the organic carbon, sulfur, and phosphorus in the rock as an energy source. In higher resolution images, the instruments found a distinct pattern of minerals arranged into reaction fronts, or what the team called leopard spots. And these are points of contact where chemical and physical reactions can occur. The spots carried the signature of two iron-rich minerals, vivianite, aka hydrated iron phosphate, and greigite, aka iron sulfide. Now, here's where it gets interesting. Vivianite is frequently found on Earth in sediments, peat bogs, and around decaying organic matter. Similarly, certain forms of microbial life on Earth can produce greigite. So the combination of these minerals is a potential fingerprint for microbial life, which would use these reactions to produce energy for growth. But, and here is the but about the whole thing, these minerals can be generated abiotically, meaning without the presence of life. Meaning there are ways to produce them without biological reactions, such as sustained high temperatures, acidic conditions, binding by organic compounds. However, the rocks at Bright Angel do not show evidence that they experienced high temperatures or acidic conditions. The discovery was particularly surprising because it involves some of the youngest sedimentary rocks the mission has investigated. An earlier hypothesis assumed signs of ancient life would be confined to older rock formations. But this finding suggests that Mars could have been habitable for a longer period or later in the planet's history than previously thought, and that older rocks that might hold signs of life are simply harder to detect. NASA even made an animation on what this life might have looked like billions of years ago, and what that same site might look like today. Katie Stack-Morgan, Perseverance scientist at JPL, said, "We basically threw the entire rover science payload at this rock." Getting such a significant finding as a potential biosignature on Mars into a peer-reviewed publication is a crucial step in the scientific process because it ensures the rigor, validity, and significance of our results. And while abiotic explanations for what we see at Bright Angel are less likely given the paper's findings, we cannot rule them out. She also said that astrobiological claims, particularly those related to potential past extraterrestrial life, requires extraordinary evidence, which leads us to the plan to potentially get the Sapphire Canyon sample back to Earth. Now, it wasn't like NASA didn't think that Percy might find something that we would like to see here on Earth. They did design the mission as a sample return effort. Since it touched down inside Mars's Jezero crater in February 2021, the rover has been collecting rocks and dirt and sealing up these samples in these cigar-sized tubes. The plan has long been to haul about 30 of these tubes back to Earth, where they can be studied in far greater detail than Perseverance's limited instruments. Katie Stack-Morgan said, "The payload of the Perseverance rover was selected with a Mars sample return effort in mind. The idea was for our payload to get us just up to the potential biosignature designation and have the rest of the story told by instruments here on Earth." But the likelihood of getting that Mars material has grown more unlikely over the past few years, thanks to delays, cost overruns, project redesigns, and budget decisions. The original plan was a joint NASA-European Space Agency campaign, with a total maximum price tag of around $3 billion, as estimated in July 2020. The goal was to get Perseverance's collected material to Earth by 2033. By 2023, however, the project's expected cost for the Mars Sample Return, or MSR, had ballooned to somewhere between $8 billion and $11 billion, and the expected arrival date of the sample had been pushed back to 2040 or so. Now, NASA knew this wouldn't work. So in April 2024, Bill Nelson, the agency's chief at the time, announced NASA would overhaul the Mars sample return strategy after incorporating new ideas proposed by agency research centers, academia, and private industry. And by January of 2025, NASA had narrowed it down to two options. One would use an agency-developed sky crane to get a lander down on Mars, while the other would rely on a commercially provided landing system. system, which basically means the MSR lander would sport a rocket, which would launch the Perseverance samples. Now, option 1 would likely cost between $6.6 and $7.7 billion, while option 2 would be slightly cheaper, falling between $5.8 and $7.1 billion. But if it all went according to plan, both could get the samples back to Earth by 2035. NASA planned to choose between the two options by mid-2026. But that does not appear to be an option anymore. With NASA's overall funding projected to be reduced by 24% next year, these cuts, if enacted, would cancel dozens of missions, including the Mars sample return. However, that doesn't mean that Perseverance's samples will be stuck on Mars forever. NASA Acting Administrator Sean Duffy said during a recent press conference, "Because we care about resources and we care about the time frame, we believe there's a better way to do this, a faster way to get these samples back. And so that is the analysis that we've gone through. Can we do it faster? Can we do it cheaper? And we think we can." Though no details were provided at the press conference, there are two companies, Rocket Lab and Lockheed Martin, that have proposed cost-efficient MSR private missions. Now, I don't really know the details of what these missions would look like. That might be a topic for another video, but I am very curious on how they would propose to do this. And speed might be more of a motivation now because there is a potential MSR race afoot. China plans to launch its Tianwen-3 mission to Mars in 2028 and get its samples back from Mars as early as 2031. And you guys know how historically America seems to love a space race. So yeah, there is a lot of up in the airness about this whole thing. Are these biosignatures? Will we get them back? When will we get them back? Who will bring them back? I mean, I suppose the one thing in all of this that gives me hope is that there does seem to be a lot of options between the space agencies and the private companies. I mean, that is one of the very fun things about this era that we're living in, is that when it comes to these kind of problems, there's not like 3 or 4 seats at the table. There are a lot of seats at the table. And bringing something from Mars back to our planet is a huge first. And I don't know who's going to be first, but I would like to see the Sapphire Canyon sample brought to Earth sooner rather than later. Because what if it confirmed that there was definitely life on Mars, guys? What if that was a thing? I suppose we'll see. Whew, so yeah. I feel like that was a journey we just went on. What do you guys think? Do you think we'll ever sort out the Mars sample return? Or do you think these are really biosignatures of life on Mars? Let me know what you think in the comments below. Thank you so much for watching, and as always, I will see you in the next video.